Hello there, welcome to the Year 10 End of Year Exam Revision Video 1. So let's get started. So this is an independent revision video. We're going to have lots of questions come up on the screen here. And what I'd like you to do with this video is to pause the video at the right moments and have a real good go at the questions. A proper go at the questions. Try really hard and don't just give up after 20 seconds and write down the answer pretending that you've done it. Then play the video to see if you've done it correctly, and if you weren't correct, then make some adjustments in a different coloured pen, make some corrections, and then maybe, if you've got time, come back tomorrow and have another go at those questions to see if you've really learnt how to do those questions correctly next time. What we've got is two stages, so you might have one stage where you're looking at a question and you're learning how to do it, and then in the second slide, you're giving the question a real good go yourself. The end of year 10 exam is a non-calculator exam, so try to do these questions without a calculator. In this video, we're going to be looking at question 1 only, and question 1 in the end of year 10 exam has lots of different subparts, and in total it contributes 12 marks towards the end of year exam. So that's why we're just going to focus on one question today, because there are lots of subparts to it. It's a big algebra question, and what you might want to do is you might want to have a sheet to the side of you to make note of the really important points that you want to identify throughout this video. Alright then everyone, here's the first set of questions then. So as I expect you to, move to the back of your exercise books, put a title of Year 10 End of Year Exam Revision Video 1, and then have a go at these 6 questions here. You don't need to write down the questions, just make a note of your answers. Pause the video and give these a go. Alright then everyone, so let's have a go at question 1 then. So the rule that you need to be aware of when you're multiplying pieces of algebra is that you add the powers. So 7 add 3 is 10. So this is x to the power of 10. The reason for this is you've got 7 multiples of x on the left-hand expression. So 7 times. And then on the second piece of algebra, you've got 3 multiples of x. And these are all being multiplied together. So to simplify this piece of algebra, you add up all of those x's that you've got there. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So your answer is x to the 10. On question 2, the opposite rule is going to be the case. When you're dividing, you subtract the powers. So 19 take away 8 here is 11. In question 3, you've got a number at the front now, so don't forget you're still going to multiply those big numbers at the front, and then you're going to still add the powers. So this is x to the 10. So don't forget you've got to mix up the rules now, so don't get confused. Don't write 11 at the front. 5 times 6 is still 30, but then you add the powers. And on question 4, you divide the numbers at the front, so 24 divided by 8 is 3, and then 7 minus 3 is 4. On question 5, 4 times 3 is 12. Then you add the powers, so make sure you get those rules the right way around. And then 30 divided by 6 is 5. And then you've got to subtract the powers, and you can go into negatives. Sometimes that does happen. 9 take away 13 is minus 4. And that's absolutely fine if you go into negatives. Okay, so if that was a reminder, then you might want to have a go at these questions to really test yourself as to whether you know these. So now pause the video again, just write down the answers. Okay, let's have a go at question 7 then. So remember we add the powers, so that's x to the 13. And when we divide, we subtract the powers, so it's x to the 11. Make sure you multiply the numbers at the front, so it becomes 35, x to the 9. When you're dividing, you divide the numbers at the front, but subtract the powers. And again, we're going to do 42, x to the 12. And then the last one, it's going to be 16, x to the minus 5. You can have a negative in your powers, so that's absolutely fine. Alright then, good stuff then. So we're now going to do some powers of powers work here. So pause the video and give these 6 questions your best shot. Pause the video and give these a go. Okay, so let's go through these together then. Let's start on the first one. Let me do it the long way and then I'll show you the shortcut. So if you're cubing something, you take the same piece of algebra and you multiply by itself 3 times. So there's 3 multiples here because of that power of 3. And what we're now going to do is we're now going to multiply the powers at the front. So it becomes 8. So multiply the numbers at the front. So 2 times 2 times 2 is 8. Then we add all of the powers together and we've got 3 things to add here and that becomes 15. So that's the answer. That's the answer the long way. You don't need to do this long way. Let me show you the shortcut way. The shortcut way is to do 2 to the power of 3. So you do the power as normal to the number at the front to get 8. And then you're multiplying the powers together. So if you've got a power of a power, 5 times 3 gives you 15, and that's the shortcut way of doing it. So you do the power as normal at the front, and you multiply the powers together. All right, if that's new then, pause the video again and have a go at 14 and 15, and then I might need to show you how to do 16 and 18. Okay, so let's have a go at 14 together then. So 6 to the power of 2 is 36, and then you multiply your powers together, so that's 14. In question 15, 4 to the power of 3 is 64, and then you multiply your powers together, so it becomes 21. Okay, for question 16, what you need to remember for question 16 is that a square root is effectively the same as a power of a half. And once you've now got it in this form, you can now apply the same rule that you did from above. So if that's now making sense, pause the video again and finish these questions off. Let's have a go at this together. 25 to the power of a half, that's square root of 25 is 5. And multiplying the powers together, 6 times a half is 3. Let's have a go at the next one, but pause the video if you would like to try this one out yourself. 36 to the half is 6, and 8 times a half is 4. Now we're cube rooting on this final one here, so 343 x to the 12. And if we're cube rooting, that's a power of a third. And you might not know the cube root of 343, so you'll have to try some numbers. Try 2 cubed, try 3 cubed, try 4 cubed, 5 cubed, 6 cubed, 7 cubed, and 7 cubed gives you 343. So doing that process in reverse, 343 cube rooted is 7. And then you're multiplying the powers together, x to the 4. So there we are, that's the answer for this set of questions here. You multiply, you do the power at the front as normal, and then you multiply your powers together at the end. Right, we're going to mix it up and do some really hard questions here now. So with these questions, look at the numerator first and then divide by the denominator. So the fraction line, remember, is a way of dividing. So treat the fraction as a divide. Pause the video and give these 3 questions a go. Okay, so let's have a go at question 19 then. So we're going to look at the numerator first. So 4 times 3 is, 4 times 8 is 32. And then we add the powers together, so that's x to the power of 5. And that's going to be over 6x to the 4. What we do from here is we then look at the fraction, the numbers in the fraction, and simplify those. It's got a common factor of 2, and I think the best we could do there is 16 on the top, 3 on the bottom to simplify the fraction. And then we're dividing the powers, we're dividing the pieces of algebra, i.e. subtracting the powers, so that's going to give us x to the power of 1. And alternatively, the correct answer would be 16 over 3 with the x on the side. And you don't really need to write a power of 1 because any piece of algebra with a power of 1, you don't really write the 1 on it. Okay, let's have a go at question 20 then, but pause the video if this now makes sense, and you're now going to have a go at these 2 questions on your own. When we do a power of a power, we get, we multiply the powers together, but we do 5 squared first, so that's 25, x to the power of 6, times 6x to the 4 over 10x to the 12. Now we're going to multiply the numerator together here, and we're going to get 150 x to the 10 over 10x to the 12. And two ways you could finish off this as a final answer. We'll simplify the fraction first, so that gives us 15. And then we can either put the x to the 2 on the bottom, because we've taken away 10x's from the top and 10x's from the bottom, or you could call it 15x to the minus 2, where the minus 2 is on the side. Both of these answers here are absolutely fine for final answers. They're actually equivalent. Okay, let's have a go at the final one here then. So 14 times 8. Okay, that's a difficult question to do. Let's do 7 times 8 and double it. 7 times 8 is 56. Double it, 112. So 112 x to the 11. X to the 11 divided by 4x to the 5. Because you square root the 16 and then you halve the 10 to a 5. Okay, 112 divided by 4, so 100 divided by 4 is 25. Got an extra 12 left, so that becomes 28. And then you subtract your indices from each other, and you get 6. So 28 to the 6, 28x to the 6 is the final answer. They were a little bit challenging, but that's all good. It's good to be challenged, so we get better. All right then, so as part of question 1 as well, we've got some expanding, we've got some factorising. So have a go at expanding all of these brackets in this question here. All right, let's have a go at question 22 then. So we're going to multiply the term at the front of the bracket by each of the two expressions on the inside of the bracket, making sure you're multiplying the numbers at the front and adding your powers on your algebra. And just a reminder with question 1, question 22 here, if it's just an x on its own, it's an invisible 1 on its power. So you'll do 2 add 1 when you get to multiplying your algebra. But here's the answer, 20x to the 3 minus 35, and then we've got no more multiples of x that we can multiply by, so we'll just have to leave it as x squared. Moving on to 23, it's going to be 48x cubed minus 60x, then is invisible 1 on this power here, and you add those powers together, so it becomes x to the 4. Moving on to question 24, 6 times 3 is 18. Then it's x to the 11 because you add the powers together. And then with this 1 at the back, we'll just multiply 6x to the 7 by 1, so we get 6x to the 7. On questions 25, 26 and 27, we multiply each of the terms from the first bracket by each of the terms in the second bracket. So x times x gives x squared. X times, now this 5 here, what students commonly forget is that this 5 is actually the number minus 5. So it's x times minus 5, which is minus 5x. This 4 here is a positive 4, so it's 4 times x is 4x, and 4 times minus 5 is minus 20. We need to simplify our answer a little bit. The only two terms we can simplify here are these two bits in the middle, because they're both the same power of x, so we can add these x's together or subtract these x's together. So it's x squared minus x minus 20. And there we are, that's the answer for question 25. Moving on to the next one, we'll do it nice and quickly. X squared plus 3x plus 7x plus 21. And to simplify the middle two terms together, that's going to give us x squared, add 10x, add 21. And on the final brackets, remember this 7 is actually a minus 7 and this 8 is actually a minus 8. So it's x squared minus 7x minus 8x, add 56. So it's going to become x squared minus 15x, add 56. And there we are. Those are the answers for 25, 26 and 27. If that's all, we're going to have a go at some factorising questions now then. So we're doing the reverse of expanding the brackets. We're going to put these pieces of algebra into some brackets. So pause the video and see how you get on with these questions. Okay, so the way you do question 28 is you've got to choose something that will go at the front of your bracket, and then you've got to put some stuff inside your bracket. The rules for choosing what you put at the front of your bracket are as such. You look at 18 and 12 and you pick the highest number that goes into 18 and 12. Now sure, 2 goes into 18 and 12, but you want to pick the biggest number at all possible chances. 6 is the biggest number that's going to go into 18 and 12, so that's 6 at the front. And then the way you pick your power of x at the front is you look at the 2 powers that you've got and you always pick the lowest power. So we've got a 5 and a 3, so we're going to put x to the 3 at the front of the bracket. Now we need to make decisions about what piece of algebra we're going to put in the middle of our brackets. So we need to think about the fact that factorizing is the reverse process of expanding. So I need to think what numbers and algebra are going to go in the brackets so that when we multiply 6x cubed by those pieces of algebra, we get this as our final answer. So we're thinking always that we're doing the reverse process of expanding. Okay, so inside the first bracket is going to be 6 times something gives 18, because I'd like them to expand to get 18. And 6 multiplied by 3 gives you the 18 at the front, so it's definitely going to be a 3. And then we need to think about what's going to go on our piece of algebra. We've got x cubed already. We need to multiply by some more x's to get x to the 5 as our final answer. And remember, we're going to be adding our powers, so I need to think about what will add to 3 to make 5, and that's 2. So you can see there that if you were to expand these brackets, you would get x to the 5. And on the second position inside this bracket, 6 will multiply by something to get 12. That number is 2. And x cubed will multiply by some more x's to get x cubed. Well, hold on, we don't need any more x's. We've got 3 powers of x here, 3 powers of x on our answer, so we don't need any more x's there. So it's just 2 at the back. So there we are, that's how you factorize into a single bracket. If that's now made sense, have a go at question 29 and 30 to give yourself some practice at doing this on your own. But let's go through the answer together now. So from 20 and 15, the highest common factor is 5, and the lowest power is x to the 7. Open bracket. 5 will multiply by 4 to make 20, and I don't need any more powers of x. So I've already got 7 at the front, and 7 is the amount of x's in my answer, so I don't need any more x's. I'll put a minus between these 2 pieces of algebra in my bracket because there's a minus in the question. 5 will times by 3 to make 15, and I need 3 more powers of x, so if I was to expand, I can then add the powers together and get x to the 10. On the final question, question 30, 4 is the highest common factor out of 8 and 4, and the lowest power is x squared. Open brackets. 4 will times by 2 to make 8, and we need 3 more powers of x so that we can add those powers to make x to the 5. On the second part of this bracket, 4 can times by 1 to make 4, and we don't need to multiply by any more powers of x because we've already got x squared at the front, and x squared is in our answer, so we don't need any extra x's to multiply by to get this answer. So there we are, those are the 3 answers for those questions. We're going to move now on to 31, 32 and 33, where we've got some x's and some y's, and roughly the same rules apply. So highest common factor between 15 and 25 is 5. Looking at the powers of x, we choose the smallest one, and that's x to the 5. And looking at the powers of y, we choose the smallest one, and that's y to the 2. Open up your brackets. 5 will multiply by something to make 15, and that's 3. X to the 5 will multiply by something to get x to the 5. We're already there, so we don't need any more x's. And y squared will multiply by some more y's to make y cubed. And we need one more y on that first term. On the second part, 5 will multiply by 5 to make 25. X to the 5 will multiply by x squared to give you x to the 7. And then it's y squared at the back. We've already got y squared at the front, so that's the answer for 31. Moving on to 32. The highest common factor between 18 and 16 is just 2. The lowest power out of 8 and 4 is x to the 4. And the lowest power out of the y's is a 3. Now we need to think about what's going inside our brackets. 2 will multiply by the number 9 to make 18. When we look at our x's, we've got x to the 4 at the front. We'll multiply by something to get x to the power of 8. Remember, we're going to be adding our powers together. So if we put another 4 x's inside the brackets, they will expand by each other, adding on the powers to make x to the power of 8. And then we don't need any more powers of y at the back because we've already got a y to the 3 at the front that will multiply on the term, and we've got y to the 3 in our answer. So when the term at the front, power, matches your answer, you don't need to put any more y's or x's if it's x's inside the bracket. On the second part, it's going to be 8. We've already got x to the 4, and now we're going to do y to the power of 6 so that the powers on y add together to make 9. And moving on to 33 then, so the highest common factor out of 16 and 20 is 4. Choose the lowest power, x to the 3, and choose the lowest power, 2 on the y's. Open up the bracket, it's going to be 4 times 4 to make 16. We've already got all of the powers of x that we want on the first term and all of the powers of y on the first term if we compare this and this. So we don't need to put any more pieces of algebra on the 4. But on the second part, it's going to be minus 5. X cubed we'll have to times by x to the 6 to make x to the 9, so that when we expand them and add the powers, we get x to the 9. And on the y, 2 we'll have to add with an extra power of 5 to make the power x to the 7 on the answer. So there we are. Now with all of these factorizing questions, you can always, on the side of your page, expand them if you're good at expanding and see if you... Right, so let's move on to factorizing into double brackets now. So pause the video and see how you get on with these 6 questions here. Alright then, so we're going to be factorising into double brackets for this set of questions here. You wouldn't be able to factorise into a single brackets because there's no common factor between x squared minus 7x and 12. So even if you wanted to do a single bracket, you couldn't because there's no common factor. So we're thinking about doing the opposite of expanding double brackets, where we will need an x at the front of both brackets to expand to give the x squared, and then we need to pick 2 numbers that will expand to give 12. So we could go with 3 and 4, 6 and 2, 12 and 1, but we probably would need to be double negative on this because we need them to expand to give minus 7x. So I'm going to show you something that's wrong now, and I'm going to explain why it's wrong and how I'm checking my answer as I go. So let's try the option of 6 and 2 to make 12. And we get x squared, great, and we get 12 at the back, which is great when we expand. Now, when we expand, we'd also need to do this minus 2 times this x to give minus 2x, and we'd need to do this 6 times this x times this minus 6 to give minus 6x. And if we were to now start simplifying this, we would get minus 8x, which is not what we want. We want to get minus 7x when we expand, not minus 8x. So we know we've got this question wrong by checking, and really important that you're checking when you're factorizing into double brackets to make sure that you've picked the right pair of numbers that will expand to give minus 12. Okay, now let's do this question correctly. If I was to go with minus 3 and minus 4, then when we expand, we get x times x is x squared. We get minus 3 times minus 4x, which is 12. And now let's look at the middle 2 terms to check if we've done it right. And when we do minus 3 times x, we get minus 3x. x times minus 4 is minus 4x, and when we simplify these two pieces of algebra together, we do get the minus 7x in the front there, so yes, we know we've done that correct. We wouldn't want to leave those marks on our answer, so we've probably done that bit in our head to leave a tidy final answer just like that. Okay, let's move on to the next question then, so apologies for my low percentage. X plus 5, x minus 4, if we expand the brackets, x times x gives x squared, 5 times x is 5x, x times minus 4 is minus 4x, and if you had the 5x and the minus 4x, this would simplify to x, which is exactly what we want. So great, we know we've done this question correctly, and 5 times minus 4 is minus 20. Now with either of these two questions here, if you've got the brackets the other way round, i.e. x minus 4, x minus 3, or if you've got x minus 4, x plus 5, then your answer is still 100% correct. As with two numbers, you can always reverse them, and when they multiply, they make the same answer. Just as with two brackets, if you were to reverse the brackets the other way round, then you still get the correct answer. Okay, let's move on to the next one now. The next answer is x minus 10, x plus 2. If we were to expand this, we'd get x squared minus 10x add 2x, and that middle term there would become minus 8x, and we get minus 20 at the back. The next one is x plus 2, x plus 5. If we were to expand that, we get 2x and 5x, which gives 7x. Or you could have these brackets the other way around, as explained earlier. Now, question 38, a little bit more different question 38. If we're going to multiply two things at the front to make 2x squared, then one of those components needs to be 2x. Sometimes what students think is that both of them need to be 2x, but that wouldn't be correct because when you expand, you get able to get 4x squared rather than just 2x squared. So one of the brackets needs to have a 2, one of the brackets is just a normal x. Then we need to think of two numbers that will multiply to make 21. So I think 7 and 3 would work. So let's try that. 7 and 3. And it's really important that we expand to check if we've got this answer correct. I'm going to do it on the side here. 2x times x is 2x squared. 7 times x is 7x. 3 times 2x, I'm now doing 3 times 2x, would give us 6x. And 7 times 3 is 21. And when we simplify this middle bit, 7x add 6x is 13x. So excellent, good. We know we've done this question correctly. Get rid of that line there, and that is the right answer. Moving on to question 39 now. So if we're going to have two things that multiply to make 3x squared, one of them is going to be a 3x. The other one's just going to be a normal x. And for minus 10, let's try 2 and a minus 5 to see if this is the correct answer. So we are going to, what's that doing there? 3x times x is 3x squared. 3x times minus 5x is minus 15x. 2 times x is 2x. And 2 times minus 5 is minus 10. And this middle term will simplify to minus 13x. Oh, we're nowhere near the right answer here. We've got minus x here. So what I think I'm going to try now is swapping those two numbers the other way round. It's a bit of trial and improvement to see how you get on with this. Minus 5 and 2. So let's expand it now. So I know that's wrong. 3x times x is 3x squared. 3x times 2 is 6x. Minus 5 times x is minus 5x, and minus 5 times 2 is minus 10. The middle component there simplifies to x, which is exactly what we want. So excellent. We know we've done that question correctly by checking through expanding our answer. All right, those are pretty tricky. So have a go at 6 more then. Pause the video and give these 6 a go. Okay, let's have a go at these questions here then. So on the first one, we've got 30. So we could go 3 and 10 or 6 and 5. I think 6 and 5 work best. So x minus 5, x minus 6. And yep, that expands to give the right answer. Remember, your brackets could be the other way around, and that's absolutely fine. For the next one, I think x plus 10, x plus 3 would be the way to go for this one, because you'd get 13x in the middle. For the next one, 10 and 7, or 14 and 5. Yeah, 14 and 5 would be the right one for this one. Minus 14 and minus 5. That makes 70, and then when you expand it, you get minus 19x. And then the last one, it will be plus 7 and x minus 6, because that will give the x in the middle. If you've got those two brackets the other way around, i.e. x minus 6, x plus 7, then you're absolutely right. But if you've got the minus on the 7, that's wrong, and that would give you minus x in your bracket. Okay, the tricky one is with the 3x squared at the front. So one of our brackets, we need to have a 3x at the front of it, and we've got 40 here. So I'm thinking 8 and 5 or 4 and 10. Let's go 8 and 5 to start with. So let's put the 8 here and the 5 here and see if we get the right answer. 3x, let's do expanding it. 3x squared, 8 times x is 8x, 3x times 5 is 15x, and 8 times 5 is 40, and when we simplify the middle term together, we're going to get 23x, which is exactly what we wanted. Great, well, we got that one first time. It's always good when you get them first time, and we did with that one. And on the next one, for 5x, we'll need a 5x at the front and an x at the front of the second one. We need minus 7 to get the answer, so let's try minus 1 and plus 7. So we'll go for 5 times x is 5x times 5x. So 5x times x is 5x squared. Minus 1 times x is minus x. 5x times 7 is add 35x. And minus 1 times 7 is minus 7. Simplify these two in the middle and you do get 34x. So great, we know we've done that question correctly. Always be checking with these factorized questions to see if your expansion is correct. And what we're going to move on to next, we're heading towards the final section of the video now, is to factorize into two brackets and then solve if the equation equals 0 at the end. So go ahead then everyone, solve these equations by factorizing. Okay, let's start on question 46 then. So we're first looking to factorize, and to factorize we're going to do x minus 5 x plus 4 equals 0. So once you've done the factorize step, you now have two. Okay, let's explain. Whenever you've got two things, and our things are brackets, and they multiply to make 0, a rule of equaling 0 is that if these two things multiply to make 0, it must be the case that either A is 0 or B is 0. What we're going to do is we're going to do the same thing as what I've explained up there, but with brackets. So now either x minus 5 is equal to 0 or x plus 4 is equal to 0. Super important you've got a 0 on the right hand side there, because if you don't have a 0, this rule doesn't work with any other number. If I was to choose the number 6, one of these numbers doesn't have to equal 6. It could be 3 and 2 that makes 6. So this rule here only works with 0. So once you've got your two little equations, you can now solve them and add the 5 to the other side and take away the 4 to the other side and get your final answers. A little shortcut is to know that it's the opposite sign of the number that's inside your bracket. So if you've got a minus 5 inside your bracket, your solution is positive 5. And if you've got a plus 4 inside your bracket, your solution is minus 4. So let's try and apply that rule to the second question in the screen here. X minus 10, x minus 3. That will be the correct factorization. And then our two solutions are x equals 10 and x equals 3. You could go through and do this little method if you like, but these are the two answers. And let's have a go at question 48 then. So we want a 2x and an x. We want to multiply to make 18. So we could go 6 and 3 or 9 and 2. Let's go for 9 and 2. Let's try minus 9 and a plus 2. I'm going to have to check this because I'm not sure this is correct. Not 100% sure this is correct. 2x squared minus 9x, add 4x, minus 18. And when we simplify the middle, yeah, we do get minus 5x. So good, we get the right answer there. Now, a little bit more complicated on this type of bracket here. We still, if you want to think of it as we need to set this bracket equal to 0, then we'll add the 9 to the other side, and then we divide by 2. So in this question, it's actually 4.5 that's the answer on that one. So you do the change the sign on the 9, so it's now positive 9 divided by 2, and you get your 4.5, or 9 over 2. And on the second easier bracket, your answer is minus 2. Alright, then so let's move on to the final set of questions for this video. Now 3 more to go, and then you finish the video. Pause the video and give these 3 questions a go. Alright, let's have a go at question 49 then. So it's x minus 7, x plus 2. And then our solutions are x equals 7 and x equals minus 2. On to the next one, it's going to be x plus 7, x minus 3. And our solutions here are going to be x equals minus 7 and x equals 3. And on the final one, it's going to be a 3x and an x. Sorry, I should have put equals 0 here, shouldn't I? Sorry, equals 0. And we want 5 and a 4, a 10 and a 2. Let's go add 4 and minus 5. I don't know if this is correct though. 15x, take away, so minus 15x, add 4x is add 11x. So no, I've done that wrong. No, that's wrong. Even I make mistakes with these. Sometimes I need to adjust my answers. Let's go for a minus 5 and a plus 4. So that will give us 12x. Take away 5x does give you 7x. Good, that's the right answer. With this slightly harder bracket, I'll always set this bracket equal to 0 and then do a little solve, add the 5 to the other side and divide by 3. I'm going to leave it as a top-heavy fraction of 5 over 3. And on the second one, your answer is x equals minus 4. Right, there we are. That's the end of revision video 1 then. So thanks very much for watching. I hope you found this video helpful. Hopefully I've explained things as I've gone along sufficiently for you to understand. Very well done if you've answered all of these questions in the back of your book, and hand this in to your teacher and show them all the great work that you've done. And if you've got time, now move on to the second revision video. There's 4 in total, so plenty more to go. Thanks for watching.